Hello everyone, welcome back to my channel. The topic which we are going to study today is ratio and proportion. So, to start with, if the topic is ratio and proportion, first thing comes into our mind, what is the requirement? Why do we need to study ratio and proportion? Why do we need that? So, basically, ratio and proportion both are used everywhere, whether it is cooking or map reading or GPS navigation, wherever we know whether it is budgeting, then also in construction, right, while mixing the elements to do the construction. So everywhere this ratio and proportion is used. So basically we need it everywhere, right? So this is the real life application of this chapter, ratio and proportion. So that is the reason we study this chapter. Now, before we start, we need to know what is the meaning of these two words, ratio and proportion. So to start with, ratio. Okay, what is ratio first? Ratio is nothing but a comparison. It is a comparison, but of what? It is a comparison of two or more quantities, right? It will always be two or more quantity, because when we have to compare, we need more than one. Obviously, you cannot compare one and one thing, right? So for comparison, we need two or more things. So comparison of two or more quantities is called as ratio. That means how many times one value is there and what is the relation of this value to the other value is ratio. Now, how do we write ratio? There are three ways of writing ratio. Okay, suppose the ratio is 3:5. So the first way of writing is in the fraction form. We write a ratio like this also, 3/5. The other way of is writing is 3:5, and the other way is writing in words, 3:5. These are the three ways of writing ratio, but generally we write only in this form. This is the basic form and the general form of writing the ratio. You can write like this, also like this. But this form is widely used. We write the ratios like this only, 3 and a colon and 5. So this is a way of writing ratios. And what is ratio? Ratio is comparison of two or more quantities. If you want to take an example, very simple example. If I say there is a necklace and there are some beads on the necklace and they are different colors, some are blue, some are red. Okay, so now if you see, some are blue, some are red. So this is blue, 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 blue and blue. If I tell me the ratio of blue to red, what will you do? We'll count the number of blues first. If you see, there are 5 blues is 2. How many red? 1, 2, 3, 4. So the ratio is 5:4 because we have 5 blues and 4 reds. So this is how we write ratio, and this is what is ratio. Same quantity but in the different colors can be two different quantities. Okay. Now the next word. What was the next word? The next word is proportion. Now, what is proportion? Proportion is nothing but the comparison. But the proportion is the comparison of two ratios. Now when you compare two ratios, that is called as proportion. So when we have two ratios, suppose there is a ratio A upon B and there is a ratio C upon D, we compare these two ratios. If the ratios are equal, they are told to be in proportion with each other, and if they are not equal, they are not in proportion with each other. So basically proportion is the comparison of two ratios. So we have two ratios here, A upon B and C upon D. We compare them. If we get them equal, we can say that this ratio is in proportion with the second ratio. But if they are not equal, we say that this ratio is not in proportion with the second one. So this is what is the meaning of the word ratio and proportion. After this, we study proportion in a little detail. Now this is proportion, right? Proportion is of two types. Proportion is classified in two types, that is direct proportion and the second one is inverse proportion. Now as the name already tells you, this is something related which is directly, and this is inverse, means which is opposite. Something direct and something opposite. Now what is this direct and what is this inverse? So direct, in direct proportion, what happens, we already know that this is a comparison of two ratios. Okay, so here it is like when one quantity increases, the other also increases, is called direct proportion. Or if the first quantity decreases, the other will also decrease simultaneously with the first one. This is called as direct proportion. Okay, let's take an example to understand it more clearly. Suppose if we have some workers, they are working for 2 hours, so they will be getting paid for 2 hours, right? Whatever is the amount, suppose 500, they are getting paid 500 for 2 hours. Now they decide to work extra. Now they are working for 4 hours, so will they be paid more or less? Obviously more. So now they will be paid double, that is 1000. So now if you see, when this time increased, now the time was 2, it was 500. Now when the time increased, this also increased. Suppose if they work only for 1 hour, so the amount will also get reduced to 250. And when time reduced, the quantity also reduced, right? So this is direct proportion. When one quantity is increasing, simultaneously the other is also increasing. Or if the first one is decreasing, simultaneously the second one is also decreasing. Okay, I hope it's clear now. Now let's move on to inverse proportion. What is inverse proportion? Exactly opposite to what we did in direct. If first quantity increases, the other will decrease. And if the first quantity decreases, the other will increase. It's exactly opposite of what is happening in direct. Okay. Now this also we'll take up a very simple example for this inverse proportion also, so that you understand what is actually inverse proportion. Similarly, we'll take the same example of workers. Okay. Now some workers are doing a work. So if there are 4 workers on a site and they can complete the given task in 4 workers can complete the task in 2 days. Now they wanted to complete faster, so they give 4 more workers. So now there are 8 workers. So the task will take more days or less. So it will be done in 1 day. So here what happened? It was 4. When the first quantity increased, the other one reduced, right? Now if they reduce the number of workers, say it was 4, now they make it 2. So will not the number of days increase? Yes, the number of days will increase, right? So here the days will increase. And when the number of workers are decreasing, the number of days are increasing. And when the number of workers are increasing, the number of days required to do the work is decreasing. So this is inverse proportion. When one quantity is increasing, the other is decreasing, and vice versa. So this is what is direct proportion and inverse proportion. Okay. Now how do we solve direct proportion? So if we have got a problem related to direct proportion, first thing we learn how to solve that. Okay. So to solve the problems of direct proportion also, we have 2 methods. One is the ratio method. The other is the unitary method. Okay. So now what do we do in the ratio method? Let's check that first. Okay, in the ratio method, we try and take, again in that we have 2 quantities, right? So what do we do? Whatever is unknown, that we don't know, we take it as x. And then we try to find the value of x with the given information. Now to explain this, I will take up a very small example. Suppose there is a machine. Okay, the machine is printing, I think, 4 books, okay, in 10 minutes, say. So now they are asking how many books will it print in 2 hours. So it's printing 4 books in 10 minutes. So how many books will it print in 2 hours? They are asking us that. So for that, first just know what are the two quantities. Okay, the first quantity is books and the other is time, right? So this is books and the other is time. And we take time in minute because here we have in minute, and this we can convert into minute, right? So they are telling 4 books in 10 minutes. As I told you, we take the unknown number as x. We don't know the number of books, so we take it as x in how many minutes? 2 hours. 2 hours is equal to 120 minutes. So 4 books in 10 minutes, x books in 120 minutes. Now just cross multiply. So what do we get? 4 into 120 upon 10. So the answer is 48. So it will print 48 books in 2 hours, that is 120 minutes. This is what is doing by this ratio method. Okay, now we will try and solve it by the same question. We will take it as in unitary method. What is the difference here? Here we don't take any x or something. What do we do? There are 2 simple steps to follow. First step is divide and the other step is multiply. And always, whether it is any question, you follow the same step. First divide, then multiply. First divide and then you multiply. Again the same question. Machine prints 4 books in 10 minutes. We have to find the number of books in 2 hours. Okay, so we know that it is printing 4 books in 10 minutes. So how many books will it print in 1 minute? How do we find that? For that we need to divide, right? So what do we divide? We'll divide 4 by 10, right? So when you divide, what do you get? 0.4, right? So now that means we are getting 0.4 as the answer. Now we'll multiply this 0.4 with, they are asking us for 2 hours, right? But we cannot keep it in hours because we have here in minutes. So we'll convert 2 hours into minutes and we get 120. So when you multiply 0.4 and 120, what do you get again? 48 hours. So did you see? First we divide and then we multiply. Again we get the, sorry, this is not hours, 48 books, sorry. 48 books in 2 hours. Okay, so again the answer is the same. If you see, 48 books and here also 48 books. Here what do? We take x and then we find the value of x by cross multiplication. But in the second method, we first divide and then we multiply. So you can use any of these methods to solve the problems. Okay. Now we will take up an example and we will try and solve it with the ratio method. Okay. We'll start an example by solving it with the ratio method. So if I tell you that there is a fruit juice, okay, which is made when we mix some juices, right? Mix juices of orange and mango, suppose, and the ratio of that juices is 9:2. Now they are asking if 189 liters of orange juice is used, how much mango juice will be needed? So how much mango juice is required? So just go through the question again. There is a fruit juice made with the mixing of orange is mango juice in the ratio of 9:2. So orange is in the ratio of 9 and the ratio for mango is 2. So if it is 189 liters of orange juice, then what is the quantity? how much mango juice is required to make this particular fruit juice. So now we again have the ratio and we have two quantities. What are the two quantities? First is orange juice and the other one is mango juice, right? And now we write the ratio 9 and 2. Now we know the orange juice. What is the amount of orange juice used? 189 liters. But we don't know the amount of mango juice. Let us take it as x and then we just cross multiply. When you cross multiply, what do you get? You get like this, 2 into 189 upon 9, right? So 42. So we got that 42 liters of mango juice will be used when you use 189 liters of orange juice for making this particular fruit juice. Okay, I hope this is well understood. How do we use ratio method? Okay, now till now we learned how to solve direct proportion, right? Now we will learn how to divide the given quantity which has been given to us in the given ratio also. And there will be a quantity given and we have to divide that quantity in the given ratio, not divide equally. Generally we do division and divide something equally. But now here we will not divide anything equally. We will divide it according to the given ratio. So suppose they tell us to divide 72 in the ratio 2:3:4, right? So they are telling us to divide 72, but we don't have to divide it equally. We have to divide it in the ratio. We have to divide into 3 parts. The first part will be having the ratio 2, the second one will be having 3, and the third one and the final one will be having the remaining part, that is the ratio 4. Okay, so the first step here is totally we add the ratio so that we understand in how many parts is this divided. So when you add this, what do you get? 9, because 2 plus 3, 5 plus 4, 9. Now this is the total of all the ratios which is given, total number of parts in which this 72 is being divided. But now do we want one part? No. For the first we want 2 parts of 72. For the second we want 3 parts of 72. And the last one 4 parts. So what do you do? For the first one we write 72 upon 9 into 2, because the first one the ratio is 2. So the answer comes up to 16. The second one again 72 upon 9, but this time the ratio is 3. So this is 24, right? Then the third one 72 upon 9 and into 4. So this is 32, right? So this when you add all of them together, you can just check 16 plus 24 plus 32. If I add them again, I get 72, right? So this is how we divide a given number in the given ratio and not equally. So when you divide 72 in the ratio 2:3:4, we get 16, 24 and 32. Okay, so this is how we divide the quantity in the given ratio. Now the last topic for this chapter is inverse proportion. We studied direct proportion, right? In direct proportion we studied two ways of solving direct proportion. One was the ratio method, the other one was the unitary method, and then we knew and we studied how to divide the quantity in the given ratio. So now the final topic for this chapter is inverse proportion. As I explained in this video only what was inverse proportion, again I will repeat it in a very short explanation. When one quantity is increasing and the other one is decreasing, it is inverse proportion. Or when the first is decreasing and the other one increases, that is called as inverse proportion. So now let's take an example and understand what do we do in inverse proportion, what happens actually in inverse proportion. So we will take up an example, and the example is a teacher is sharing sweets. Okay, sweets among how many students? 8 students first. Only 8 students are there. So they get 6 each. That means when there are 8 students in the class, everyone is getting 6 sweets each. Now they are telling that they have 12 students. Now we have how many sweets will each get if there are 12 students. Now that means first the number of students were less, right? But now the number of students are more. Okay, so now what will happen to them, the number of sweets? So first there were 8 students and they were getting 6 each. That means every student were getting 6 sweets. Now the number of students in the class have increased. Now there are 12 students. Now what will happen to the number of sweets? Again we will do it by the ratio method only. Now we have two quantities. What are the two quantities? First is the quantity is student and the other is sweets. Okay, so when there are 8 students, they are getting 6 sweets each. Now the number of students are 12 and the number of sweets we don't know. So what do we do in ratio method? We take it as x. Now is the change. What we used to do in direct proportion, we did cross multiplication, right? Here we will not do cross multiplication. We will just multiply them like this, straight in front of them. So x will be 8 into 6 upon 12. So that is 48 upon 12. So that will be 4. So now when there are 12 students, now 12 students are there. So everyone will get 4 sweets each. So now you understood why this is inverse proportion. When there were 8 students, they were getting 6 sweets each. Now the number of students increased. So the number of sweets decreased. So this is what it says, inverse. When the number of one quantity is increasing, the other quantity is decreasing. So this is what is inverse proportion. That is the reason we call it inverse proportion. It works inversely. Okay, so the number of children are increasing, the number of sweets are reducing. So that's it for the lecture. See you in the next lecture. If any problems or any doubts or queries, please post in the comments below. Thank you for watching.